Alright, so after we've turned the switches on, we are going to go ahead and open up WSX Expert shortcut. Double click on that. It's going to say laser is dangerous. Please use it carefully. That's probably added by the lawyer, so we're just going to hit yes. We'll definitely use it safely. Alright, so here is the menu you're going to get dropped into. We've got object view already starts open usually. Clicking that will toggle whether it's open or not. The first thing that we're going to do, this is stretched a little bit because I have it on a different screen for doing the capture. So the first thing that we're going to do is hit Go Origin. It's very important to look inside the machine, make sure that somebody didn't leave anything inside of there that could get damaged because this is an automated function. And know where the emergency stop is in case something goes the wrong way. So we're going to hit Go Origin. So that the Z-axis is going to go up first, and it's going to bump into its stops, and it's going to bump in a second time to try to get a consistent read on its height. Then it's going to move the XY together until it finds the limit switches there. I don't think that these were intended to be high precision limit switches. However, they do seem to work pretty decent, as most of the time I boot up the machine, I don't have to adjust anything. Now there's a set of parameters that can be adjusted for the size of the table area as well as how far it comes back. I had to tweak this on my machine. Not sure if something moved in transit or it wasn't quite set up right from the factory. So here it is now homed. Most of the time you'll need to adjust the Z-axis, and we'll do that. We want to make sure we're running slow. You don't want to do that at 20 millimeters a second. The Z-axis is a little limited on speed. We're going to go Z negative to lower it down. You'll be able to see it, but there's another screen for telling when you're at the right height. So that is how you boot up and home the machine. So here in the layer menu, we've got a few options here for our power. Power, when it's at 100%, is going to be using, in my case, all 750 watts of energy. The duty cycle, though, if you have it like this where it's 110, it's going to be on 10% of the time. And the frequency, so in this case 10 hertz, it's going to be on a 1/10 of a second cycle. For that cycle, it's going to be on 10% of the time, and then off 90% of the time every 10th of a second. Now if you do a little bit of math with the process speed, the duty cycle, and the frequency, you can actually figure out how often your laser dots are going to be. And generally for most of my welds, I like to be nearly 100% power, and I like to control with the duty cycle. So it's going to throw a very powerful beam and then shut off and allow the puddle to cool, instead of just running a dimmer laser. So now you kind of understand that between the process speed, these four, and the laser height, you can get a lot of variations. And because there is no note section, which would be really nice to have on these layers, you're going to probably need to keep some kind of notepad for what layer does what, and it gets a little bit complicated to save these, as we're going to see a little later on down the road. Alright, so let's say you have your project here. You've got your layers exactly how you want, you know. Maybe you have a few things that are on a different layer, okay? And you want to save all the information, and you want to save, you know, the things specific to what you're doing, so that way next time you want to do this exact same part, you can do that. How do you do it? You'll hit Save As, and on mine, I made a file on my desktop that I call Laser Docs, and we're going to put it stuff for YouTube videos, and we're just going to give it a name, part, if I could spell like, it'd be awesome, but alright, there we go, part 1, and it's going to save as a welding file. Now this is one of the drawbacks of this program, is it only saves it as a WXD. I'm guessing that's probably their company's file type. It's good and bad. It's bad in that you can't open it with anything else, but it's really good in that when you hit save and you bring it back up, it saves not only the data of where these parts are, the direction, and everything else, it saves every single layer, okay? There is a awesome part of this in that if you have multiple layers, it will save the data specific to each one of those layers. The drawback is if you're programming something else and then you go and open the file, it's going to overwrite your layers. So it's very important. I haven't yet found a great way to save information. It does save to the project, so that's good enough for me for now. But it will overwrite if you're working on something else and you open a document. This is how you're going to save layers, and you don't want to save, let's say, a DXF, or you're not trying to save it to something specific. From the layer menu, if you click up here in the layer and you get to here, you can hit export. And export laser docs. I've got welding saves here, and I've got several different types of parts. So this is the one I was using today, 22 gauge tab welding, 1008 grade, good finish I named it, because this one wasn't so great and this one was better. So you can just click on it, give it a name, you know, let's give it, you know, just whatever, tab 1, whatever. Save it, and then when you go to so what it saves is it saves all 15 layers and all the data on it. And when you import it and you go to import that same thing back into it, it's going to overwrite all 15 layers. It's not like SipeCut, if you're familiar with that, where you go and you get one layer, and so you can be like on layer 5 and then you click load and you can bring in one layer worth of data. It does all 15. Now this is great and it's awful. It's great in that if you have sets of parameters, like you're maybe welding next to an edge so you have a lower power setting, or if you're welding in a field and you need more power, you can have different layer settings so that the machine will work for your exact part and your exact needs. That's great. But if you save that and then reload it, it's going to overwrite other layers. So it's something to be aware of and to be careful of. It's good in certain circumstances, bad in others. Just pay attention to it. It overwrites everything when you import a drawing or a set of parameters. Just be aware of that. How to calibrate your laser. So we're just going to click the laser button and hope it turns on. Okay, I can see it's making smoke, but I don't. Why is it just doing that? Let me go in here real quick. Okay, power. Let's. I know 25% power will put a black dot. I'm pretty sure. Let's try that. There we go. Okay, great. So we can see that the laser dot is crooked. So all we're gonna do. So up here, there's a couple of knobs. I'm just going to turn them. So I'm touching the camera, so that's probably why it's wiggling. So that's that axis. This camera unfortunately wiggles when you touch it. Alright, there we go. So that's all you got to do. I can go ahead and move it over just a little bit. I'm sure it's correct. So I'm just going to move over just a little. Tap the laser button again. There, nice and centered. That's what we want to see. So to start off with, let's familiarize you with a few of the work areas. This large center section is the area where you're going to see the parts that you're going to be welding. This is just a very simple two-dimensional sketch area. It does not work very well for manually drawing all of your parts. However, this is a very good area to edit your components. Over here on the left, this is called the object view. You can turn this off and on by clicking the object view button. And here will be a list of parts that makes up your welding area. Here is how you turn the laser on. and off. So I'm going to leave it off for now just so I don't have an accident with the machine. So here are some of your controls for your X, Y, and Z axis. It's very important to have this set for 10 millimeters per second or slower for adjusting the Z axis. The weight of the head on the stepper motor has a tendency of causing it to skip if it's set too fast. You can adjust it when the fast speed is unchecked. You can click here and you can select any speed you want. Click OK, and that will edit that box. The maximum speed, I'm not sure what it is. I've been running 50 millimeters per second and it has been working just fine and does not seem to lose any steps. Over here you have a step function. This is very good for dialing in your to adjust your crosshairs to exact corners, which is very important, particularly on my machine since I don't have a wobble head. My welding area is very tight, so it's very important that I'm very close. A few of the not so refined components of this software is, let's say I type in 0.1, it misses that point. You actually have to type a 0 first. It's just a subtle annoyance, but it's something to be aware of. The step function works in the X, Y, and Z axis. We're going to uncheck the step and we're going to adjust the Z axis down until we can see it better. Actually, but first I'm going to move the Y axis over on top of the part that I'm working. You can see it's all blurry. So we actually use the camera to judge the height because it only focuses in a very small area. So we're going to go ahead and move the Z axis down and you're going to see this get really clear. I've gone too far now. I need to go back up a little. And that looks pretty good. You can adjust your weld dot size by adjusting the camera's focus. It's one of the knobs on the camera. I don't remember which one it is, so you'll have to tweak it a little bit. There's also two knobs on the back for adjusting the camera's crosshair. What you'll do is you'll fire the laser and then you'll adjust the crosshairs to the center of the burn crater. It's pretty easy to do and self-explanatory. So we're going to go ahead and jump into some manual programming. So right now, as you can see, the center area is blank. There's nothing here. So we're going to go ahead and move up and over a little bit. And we're going to weld this from the outside in. Now to start with, I'm going to go ahead and locate the corners. A thing to pay attention to is this machine is going to record not only the direction or the order of the points, but the direction that they're in. And, sorry, I said that a bit confusing. It's going to record the direction you select your points in. So for instance, if you select this corner first, second, third, fourth, it's going to weld in that same order. As well as if you program this section first and another section later, it will weld the first section you programmed in the first position and the second in the second. That will become more obvious in a second. So let's go ahead and click the Teach button. So in Teach mode, you want to make sure this continuous is unchecked. That is useful for certain things, but not for this because we have multiple areas we're welding. We have point, we have line, idle run, circle, arc. I don't use most of these functions. All of my stuff has been in straight lines. So we're going to click the line button, and that's going to put a first point down. Uncheck the step button, and we're going to move down until we reach this corner. Reselect step, step it to its final position, click the line button, and that's probably close enough. I'm just going to leave it in step. Click the line button again, uncheck the step, recheck step, and move up. And I'm just a hair crooked. I'm going to move it over one. I don't think this is on an angle, but I might have been off on my first one. We're going to click line again, and now I'm going to zoom in on this. You can see I've drawn that rectangle. That doesn't look the most straight. Alright, so I can actually fix that right here. So we're going to uncheck the Teach box. That's going to kind of lift the pen. Right now we're drawing until we release that. We're going to select this. I'm just going to move this over just a little bit. This is actually really easy to do. just to kind of re-square it. There, that looks a lot better. You can also change what layer this is on. In my case, I'm using layer 4. You might need to keep a separate notepad to note which way you're doing this. So let's go ahead. We're going to bring up parameter settings. This is password protected on my machine. It is 66, 66, 66. Very easy. Hit OK. And we're going to go to other parameters. This is one you need to get to. Okay. Empty speed is kind of the rapid traverse speed that the machine is going to move from one weld to another. So if you want to save a lot of time, turn this up as fast as the machine will go. I've been running 50 millimeters a second. It does not lose steps at that speed. Faster, you may be risking things. I'm not sure what the max is. It might be 80 millimeters a second, but 50 is pretty safe. It also controls the speed that idle run operates at. So 6 millimeters a second, we can see what's happening. So we're going to click OK, and we're going to click idle run. And this is going to move right around. All right, that looks pretty good. However, one thing I don't like is that if you look at the start point, it starts right on the edge of the part and goes around. So we're going to grab this, and this is one of the things this software does really good, is editing lines like I've already done once. We're going to click on that yellow start point, and we're going to move it up. Now, one thing I don't like is it grabs onto the darn background a lot, and this is, I can't figure out how to turn this off. It's not that frustrating, but it's just a little annoying that I can't turn it off. But so we're going to just move it up about like so. We're going to click, and we're going to hit idle run. Now, another thing you can do, you can select stuff, and you can click only process selected shapes. You can also tell it to return after finishing process, and I'm going to select to start. So it's going to go back to the start point. So let's click idle run and see what that looks like. Now it starts. All right, see where it's starting right there? That's the start point. This is really important to do a clean weld, is you want to start somewhere on smooth metal and then go into your weld. And what that causes is the drop of metal to jump into the joint, which causes the metal to bond together. And once it's connected, you can you can kind of chase that metal drop across the whole joint, and it does a much better job. Just one more time just to see it. Okay, now let's program up one more, at least, so you can see how to add another one. So we're going to move down. I managed to stop at just the right spot. Click the teach button. Click the line button. Now this is where it's important that that continuous is not checked. If that box is checked, it will draw a line from my stop point over to it. But it's not checked, so we're going to click line. We're going to back up from this a little bit so we can see what we're doing over here. All right, we're going to move down. Tap that real quick, and it does a nice job. Click line again. That's going to draw a line. That looks all right. Click line, and then we're going to go up. Click the little step box to make that a little easier, and we're going to click line again. We're going to leave the teach section. We are going to select this, and again, just like before, I'm going to go ahead and move it up a little bit. All right, so now we have these two. I can show you another thing. Note over here in the object management, I have two different plain linear lines. This one, if I click select, I can select that one, and they also have a number. So every object you draw in the software or import will each get a unique line segment number, okay? So this is the order that they're going to be welded in. It'll weld 1 and then 2. Now, if you have only process selected shapes and you only select that one, whatever shapes you select, it will order them in from the lowest to the highest number. Comes in handy later on. But for now, we're going to uncheck only process selected shapes. So it's going to weld everything that's on the machine, and it's going to return to the start point. So we're going to turn the laser on now. And I'm making sure my camera is still rolling, right?
Yep.
Okay, cool. We're going to close the safety door. So I can no longer see what you guys get to see now. And hopefully that doesn't crash into my laser, or into my camera. So we're going to press the start button. Now an odd glitch does happen sometimes. It sometimes doesn't weld for the first half second or so. I think it's a software problem. But there's another way of avoiding that, is you put a small section of line away from your area. You can have it weld that on a low power and then weld the rest of your stuff. Also, if you make that your first line and you tell it to go to start, you can actually set that up so that the table advances out to the door. For instance, if you were to put a little line segment up here, it trying to move that way is going to present the parts out next to the door and make it easier for your operator to get to. Great way to do that. So let's go ahead and click start. Like I mentioned before, in that parameter settings, that's set to 6 millimeters a second. Let's go ahead and swap that part out just so I can show you the difference. So I've got a bunch of these little parts. Let's go ahead and just put another one in there real quick. Great reason why your stuff should be consistent. So let's go into parameter settings. It's 6 6s. And other parameters. And let's crank this up to 50. And you can see how fast the machine's going to move between the welds. So it doesn't affect your welding speed, but watch how fast it goes. Much faster. All right. So that pretty much covers how you would manually program some parts. So let's go ahead and show you how you can import some DXF files and do something similar to save yourself a bunch of time. So now we're going to show you how you can import a DXF file. The parts that we're making, just so you have something to look at, let me go ahead and move this over a little bit. So here's one of the parts that we made. Let's go ahead and import a DXF file. So I have not touched any of this stuff. I'm losing my voice from talking too much. We're going to hit removable disk, I think. Alright, here's the piece I made. Nope, it's a different take. It's this one. So this is the same exact file I used to cut this part. I would hope that if you have a laser welding machine, you probably already own a laser cutter. So boom, just like that, we have now imported a part. Now the trick with this is, how do you synchronize where this is with where it is in real life? Well, that X down there is where the scope is. So let's just go ahead and grab this whole chunk. And let's just get it close first. Alright, now we're going to select the step mode, and we are going to step down. And I think we want to step one over. Yeah, that's pretty good. Okay, so now I had to click over here so I could zoom back, reselect this, and where you're at in looking through the scope is right on this joint. So we're just going to select out here in the middle of the line. Remember, if you select one of these white boxes, it's going to move the geometry of the part. Okay, so we want to weld this, but we don't want to weld the outside edge because that is not a part. So like most CAD drawing software, if you select left to right, it will only select what is fully inside the box. And if you go right to left like this, it will do everything it's touching. So in this case, we're going to go left to right. And somehow that was not inside the box. I'm not quite sure I missed that. Try it again. There we go. Okay. Now we're going to check only process selected shapes. That's one way of doing it, and because I had to click outside of there. Alright, you could do that way. Let's see if I can just delete this outside edge. There. That's a much simpler way of doing it. And let's go ahead and check idle run and see if this worked. No shape selected. Oh, right, because I checked the box. Uncheck that. And idle run. I might need to slow that down a little bit so you can see. Okay, another important thing is these are being done in exactly the same order that they were drawn in. Obviously, I did the two sides first, and then I did the ends. Let me go ahead back into that parameter setting real quick. I do hope in future updates that they put this setting outside of this setting, this area, so I can actually, use it. It'd be awesome, but this works for now. Okay, we're going to do idle run one more time. There, that's much better. And this was obviously a lot simpler than using the manual teach. So if you have the DXF file that created the part, this is a great way to do this. Alright, I'm already getting bored with that, so I'm going to hit stop, and let's go ahead and crank that speed back up. This is a little bit tedious. Let's go ahead and turn the speed between back up, and let's go ahead and weld it. It's green means it's on, right?
Yeah.
Yeah, it's on, okay. Oh, I made a mistake here. So it imports as layer 1. Layer 4 is what I have programmed. Let's try that one again. It's a little slower, but a much more reliable weld. So this took, just a few seconds of programming versus about 10 or 15 minutes. Okay, one thing I will point out, a mistake I made is, you can see here, the weld dot is just a little to the left. Obviously, I need to recalibrate that a little bit. So, my mistake on that. It's not the machine's fault, it's the operator. I gotta fix that. But mostly, it's doing a pretty decent job. Alright, so that worked out really good, and that would be fine, but let's say you were making 20,000 of these, and every second counts because, each second is 20,000 seconds. So we saw that we did this one, this one, this one, this one, this one, this one, this one. Wouldn't it have been great if it did this one, this one, and this one? Let's see if we can change these around a little bit. So here in the Object Manager, which, again, this is pretty decently done, we can select this, or we can select it out here, and it shows us which one it is. So there's 2, 3, 4, 5, 6, 7. I want this one to be 8. So we can just click the up button until that one is 8. Boom. That one's now 8. I want this to be 9. And it's going to just move everything around. So all of these parts, their numbers are changing depending on where they're at. So does it do this one? 10, 11. Okay, this is great already. It did that in order. 16, 17, 18. Okay, perfect. Now we've got it going all the way around. Let's just go ahead and do an idle run just to confirm that it in fact did do it in the right order. So it's going to do that one, that one, that one. There it is, just like that. We've now edited this for maximum speed. You could reuse this in a bunch of different configurations to weld components. And I think that worked out pretty decent. So let's move on to showing you how to do this one other way. So now we're over on my desktop computer. This is the one I use for design. In this case, I'm using TurboCAD Professional 18.1. I'm not recommending this software. I'm just saying what I'm using. The software is good for doing little simple 2D manipulation on parts. It's not super great for designing things. There's no parametric modeling, but if you just need to make a quick edit, it works pretty decent. So the first thing we're going to do, most drawing software will have an area where you can open up a layer tab. We're going to add a layer. We don't care. You know what? We're going to give it like welding. That misspelled. Let's try that again. That looks better. Alright, so we're going to give it another layer. We're going to change the layer color to something like red. That looks great. Now we're going to grab polyline. Now if you draw with individual lines, they come back up as individual lines in WSX. So we're going to click polyline, and in my software I can tell it that the line color is going to be by layer, and I'll pull up that welding layer line. Now I'm just going to do this kind of by hand. You could use a bunch of constraints and stuff to make these lines perfect. I'm just going to kind of eyeball it. I'm going to start off of the part, go down to the corner, go to the next corner, start, finish off of the part, and then for some reason WSX deletes your last line segment. So I'm just going to click over here, and I'm going to then click the finish button, which is Alt F, and I'm just going to leave that line segment. So this piece will end up getting deleted by WSX. I don't know why it does that. It's a weird little bug glitch. I'm not trying to fix the software here. I'm just trying to use it. So I'm going to repeat that same thing through the rest of this. So now I've gone all the way around. I want to mention a couple of reasons why I'm doing the things that I'm doing. So for some reason in DXF files, not only the position of each line is recorded, but also the order that the lines is recorded, as well as the direction they were drawn in. Now this is huge for programming off of the welder. So this was the first line I drew, and I started here. So that's actually going to be where the weld is going to start. It's going to weld along the outside, go in, and then weld the inside. And like I said before, this last segment is going to get deleted in the transfer for some reason. Enclosed things like squares and rectangles, those will be fine. They can come over. In fact, I'm going to go ahead and just throw one in here. And this is also on welding layer. And I'll delete it before I draw it, just to show that it does in fact come over just fine. Before we leave here, we're going to turn off the welding layer, and we're going to select all the other stuff, and we're going to press delete, and then we're going to hit file save. As.
Yeah, save as.
For YouTube. Perfect. Save. Okay, so now we've just come back from the computer, and we're going to go ahead and hit import DXF, and we saved it as this one, box for YouTube. Okay, yeah, this is that save. So here are the lines, and as you can see, it did in fact delete that last segment off the end. No big deal. And I believe this is going to be line 1, 2, 3. So this is really good if you're doing complicated components, or where you're doing a ton of parts on a sheet, and this software is not as good at duplicating components. If you do it on another computer, it works out a lot better sometimes. So 4, 5, and you can see that here's the start, the weld's the outside, and then in. So just exactly the same layout of drawing is done. Why are these so skinny? Oh, it's not skinny. It's my screen is skewed because it's stretched because it's not the original thing. All right, this should be the last piece of geometry because I drew that last, and as you can see, it is the very last, number 19. All right, I'm going to delete that one, and as you can see, it didn't delete any segments. I only brought it over here just so you could see it wasn't messed up. So I'm going to get rid of that because I don't want it welding out in the middle of the part. Again, same as before, we're going to move the machine over to any one of the corners or any one of the facets that you can easily identify. So I'm using the back left corner here. Now, in this situation, it's very important to pay attention. In this situation, I extended these legs past the end. So it's very important not to use that corner, but use one of the fixed points that are definitely at an intersection. So we're going to go ahead and move down, and we're going to move over a little bit. I'm going to click the step button. Select all the parts. Grab onto the middle of one of the lines, not the end. Otherwise it causes problems. Get it close. We're going to zoom in now. And we're just going to grab again the middle of the line and line that up with the crosshair, that yellow X-shaped crosshair.
Oh, we just lost our other video camera.
Okay, camera gear, man, it is crazy. All right, so I kind of lost my thought because that happened 5 minutes ago. So we want to use this inside corner here, or this corner that we know where the weld is, and that's the same as right here. So we've already got it lined up now. Let's go ahead and slow the parameter settings down just a little bit. And again, it's another parameters, I don't know, 10. I don't feel like watching it in slow motion. And we're going to hit idle run. So it's going to start there, weld there. Again, starting off the part. Okay, honestly, I'd say it looks pretty good. I'm going to wait for it to round the corner. Okay, I'm just going to click the stop button, and I'm going to go back into parameter settings again. And I'm going to go ahead and crank that back up to 50 millimeters a second. That's kind of the rapid traverse. So now it's going to rock it back to the start and go ahead and weld everything. Oh, one more thing I almost forgot. Select it and select the layer that you've programmed. Just in case I haven't shown it in a while, layer 4, just pause it here and copy this if you want to use it yourself. I'm not using the automatic power regulation. Alright, so that is now set up, and we're going to hit start. And you can see that weld, it's dead on the center. So recalibrating the crosshairs helped that out a lot. So this is with no shielding gas. I've mentioned that before. This is just atmospheric air. That hissing sound, that's just the air knife. That's not any kind of shielding gas. So this is only using electricity as a consumable and nothing else. Alright, so there we got the last couple things, last couple of useful tools. I don't use these often because I normally would do this in other software. Up here we have mirror horizontal, so it's going to flip it backwards. Mirror vertically, that's going to flip it upside down. You can do array copies, rotate. So you can do, you know, like 90 degrees or something like that if that's useful to you. You can do a few things in here. Some of these aren't the most useful features, but they can work pretty decent for some applications. But that pretty well covers most of the programming that you need to do as far as dialing in the laser for your specific application. You know, I only use this machine for certain parts, so this is pretty much all I have. So I might make a few recipes down the way for other thicknesses of material. They'll be on separate videos because this one's probably getting pretty long as it is. But otherwise, if you come up with good recipes, post them on the internet. You know, make it useful for other people so people getting started can get into this and do the same thing you're doing. Alright, so we're going to do one more, kind of a bonus round. So this is just importing the actual cut geometry, and this is where programming on the machine using the teach command really is not a good option. So we've got a straight line, a tangent arc with a 1 millimeter radius going up, a 30-degree back angle, another tangent radius, 1 millimeter, and a little puzzle piece. Now this part, if you're looking at this and saying, wow, that doesn't make any sense to do that in the middle of a part, you could have just cut that square. Yeah, that's kind of the point. This is just an example. I have seen a number of enclosures with this kind of joint on the back. Typically, if you have a 4-sided box and you want it all out of one piece of material, you're going to have a joint on the back. Now, that could be a straight joint. The advantage of doing this kind of puzzle piece type joint is that you can connect them together without any external fixturing. I've seen this done where they use a resistance welder to obliterate a few points. I've also seen them use what do they call it? Like a prick punch to compress the material at the edges to smash them together. It's not a great way of doing it. Lasers really win in this area because this would be very hard to manually weld, especially fast, which is what we're going to do here now. Well, fast is limited. So I'm going to change the part out right now. And I kind of have to, this is not symmetrical, so I got to count the puzzle pieces, make sure, yeah, that's lined up the right way. So I'm going to go ahead and load that in there now. And since we're going to go ahead and change all of this to the layer 4, we're going to delete the outside because that is definitely not used. Alright, and I'm going to go ahead and grab and move this to where my cursor is, same as every other video I've been doing. Okay, so we're going to uncheck step, go down to a reliable intersection corner, tap this a couple of times, go back here, select our part, and we're going to move it. I guess I could have used the top corner because this does not, this is just using my DXF file. So this is not a special program file. This is actually using the exact DXF that I used to cut it. Alright, so in this case, I really only want to weld the butt weld. Let's see if it turned out. Oh, no. They're all separate pieces. It's not a... Oh, man. Crud. Alright, well, this turned interesting. Alright, it'll work, but it's going to be messy. I don't really want to fix it for the video, but it could be fixed pretty easily just by editing a few things. I'm going to delete all the geometry that ain't what I want to do. Oh, man. Yeah, you know what? I'm going to fix it real quick. It really doesn't take that long. So we're going to want to weld from there. So we want to make that number 1. That one I want to be number 2. I got to show you a few things not to do. So that's 3. I want that to be 24. And I think in edit, if I click reverse, it'll switch directions. It does. Perfect. 5. That one's correct. I want that to be 6. 7. That one's right. That's supposed to be 8. That's 7. 8. So that's supposed to be 9. That's supposed to be 10. 11. I want that to be 12. And reverse to face it the right way. Should be 13. That to be 14. 15. 16. 17. I want that to be 18. 19. 20. And reverse to get it facing the right way. Now it's gonna, if you have any, I lost count, 20, 21, 22, 23, 24, 25. Okay, I'm gonna make one quick little edit to this, just because I don't want it wasting any time. I'm gonna get rid of the blow delay, make that 0. Just so that way if it's starting and stopping, it will just continuously weld. Okay, because each one of these, the yellow is the start. I don't know if it comes through in the video, but there's a little arrow here you can see very easily what way it's facing. That's how I knew if I had to click reverse or not. So let's, I don't need to select anything. Let's just hit idle run. I always like to close the door before hitting idle run because I have accidentally hit start one time now. I'm not blind, but that was definitely dumb. So let's go ahead and hit idle run. Wow, that is crazy fast. Okay, and this is a good example where programming off the part. Oh, I do not want to start right here. So again, very easy editing. Let's just move that away from the start point. And I'm betting the end is going to do the same thing. I don't want to scorch my table. So, let's just, boom. All right, real time. That's how long it took to fix this. Now at this point, you would take this and copy it into multiple parts. That way, all the geometry is in the right order. So let's go ahead and hit start, and let's see how it does. So you can imagine trying to TIG weld this and how much skill it would take to be able to weld this perfectly, where I'm just sitting here at a table sipping coffee. The video stopped, didn't it?
It did, yeah.
Of course. Man, this is hard to get all this to work.
You got enough.
I'm going to do a synchronize at the end, that way we can back it backwards, okay? There we go. So you can imagine how hard that would be to do with TIG. So lasers are really the way to go if you have repeated parts. So in the laser cutting videos, you always see people put their hand right on the part after it's been cut. That works on cutters. Welders are melting the material on purpose. So this is really hot. I wanted to show the part. This is using the exact same configuration of welding. I did leave the welds off at the end so I could pry the end open just to get better inside of it. I welded both sides, as you can see. We're going to go ahead and pry this apart. It's kind of a worst case scenario, but let's go ahead and show you how strong these welds are. Let's try to get this in the center as much as we can. Try not to bust my knuckles. I know, I'm getting a little nervous myself. I don't want to bust my hands. You know what? I think that pretty well demonstrates it right there. I think that's adequate. As you can see, oh, sorry, I'm out of camera view. That was a very impressive amount of force to try to open it up that much, and it held on no problem. So, yeah, I think that's a pretty decent weld right there.
You get the 3-footer?
It's under the desk over there. Dang. Okay, so
we will get the results.
I can't get that one out of there.
Okay. What did you do to me? Oh, I see. It's bigger. Okay. Well, it's a failure of a test. We can't break it.
We failed at testing.
Failed at testing. One second. Make it more flat. One for. Okay, there we go. All right, flatten the back of the vise so we can get the jaws in. We will get results. Can you help me there? Okay.
This makes me nervous.
Yeah, I'm actually.
So you get a busted finger, I'm pretty sure. All right, you know what? I pass. This is
it's working. It's working.
and this weld is done with no shielding gas. This is. Yeah. Go ahead and show it close to the camera.
Go ahead and you hold it up, and I will focus on it because it's not on autofocus.
Okay. So is that
right there?
All right.
And you can see you can actually see the little puckers in the weld where it's pulling the weld down in, and the weld is as strong or nearly as strong as the base material. So that's pretty impressive. Let's go ahead and get that. We're going to get that zigzag weld there, that puzzle piece, and break it next.
We've got our little puzzle piece weld. We broke it out of its original piece, and we've clamped it into our vise very firmly. And let's just go ahead and try to break it. Again, this was done with no shielding gas, so. Well, that did not have as much clamping force as I thought. And I think this side has better clamping, so let's go ahead and
pretty ductile weld.
Go ahead and grab her right. Let's grab her right next to the weld. Try to bend the weld.
I think he did achieve breaking the weld. So, yep.
Yeah, it did break finally. I mean, it might not be an airtight weld, but
yeah, I'd say if you were welding things on, like, heart valves or something like that, you should probably buy a welder specifically made for that. But this is like 85% or 90% of what you'd use a laser welder for. This is going to be fine.
Or at the very least, use shielding gas.
Yeah.
But yeah, I don't think we're going to be able to break that in any kind of reasonable way. And I can.
You broke that one. It's broke through. You can go down to the next one. It just snapped off. It just followed the brake line through.
Yeah, so it broke.
That's kind of illustrative of a relatively good weld, is that it's.
Yeah, it's not wanting to break on the joint. It's breaking next to it. So that is actually a really good weld. Again, it might have some porosity, but that's probably from not using any shielding gas. So, pretty cool.